And good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see about the third unit, nuclear chemistry. So, coming to the syllabus here, in nuclear chemistry, you have natural radioactivity, detection and measurement of radioactivity using Geiger-Müller counter, then Geiger-Nortel rule, rate of disintegration, half-life period, average life period, nuclear stability, N by P ratio, magic number, mass defect, binding energy, liquid drop model, shell model, isotopes, bar, tones, isomers, artificial radioactivity, then fusion and fission, its mechanism, application as well as differences, then stellar energy, nuclear reaction, hazards of radiations, fissile as well as fertile isotopes, application of radioisotopes, carbon 14 dating, rock dating, neutron activation analysis, isotopes, then traces and reaction and its reaction mechanism. So this is the syllabus of nuclear chemistry, and for today's class we are going to see what is radioactivity and how to detect and measure radioactivity using Geiger-Müller counter. So this is the topic you are going to see for today's class. So I'll start with natural radioactivity, and I am going to explain the detection and measurement of radioactivity using Geiger-Müller counter. Okay, so first we can see what is said to be natural radioactivity. So Henry Becquerel observed that salts of uranium emit spontaneous some powerful rays which affect photographic plate and ionize air. So this was observation made by Henry Becquerel. So what was observation is salts of uranium were emitting spontaneously radiation or rays which affects the photographic plate. Also it ionizes air, and these rays are called as radioactive rays. And the phenomena of spontaneous emission of radioactive rays by heavy elements like uranium is called as natural radioactivity. Is it clear? So I'll repeat So Henry Becquerel, what was his observation was, he observed that salts of uranium emit spontaneously some powerful rays which affect the photographic plate as well as ionize air, and these are called as radioactive rays. And this spontaneous emission of radioactive rays by heavy elements like uranium is said to be natural radioactivity. Is it okay? And coming to this radioactivity, it is unaffected by external factors like temperature, pressure as well as chemical nature. So it is therefore a nuclear phenomena, radioactivity, is exhibited by several elements. That's heavy elements of mass number greater than 200. That is radioactivity is exhibited by several of the heavy elements of mass number greater than 200, and few examples are given. They are nothing but uranium, polonium, radium, thorium, plutonium, etc. Lot of things we have, and these elements which exhibit radioactivity are called as radioactive elements. It's clear? I'll repeat. So radioactivity is exhibited by several heavy elements of mass number greater than 200, and few examples are mentioned here: uranium, polonium, radium, thorium as well as plutonium. Is it okay? These elements which exhibit radioactivity are called as radioactive elements. And next topic what you are going to see is detection as well as measurement of radioactivity using Geiger-Müller counter. I'll repeat: detection as well as measurement of radioactivity using Geiger-Müller counter. So coming to Geiger-Müller counter or GM counter, it's a most valuable device used to detect as well as to measure alpha, beta as well as gamma radiation. புரியுதா? ஸோ இந்த Geiger-Müller கவுண்டர் அல்லது GM கவுண்டர் வந்து ரொம்ப பெக்யூலியர் அல்லது வேல்யூபிள் டிவைஸ். எதுக்கு சொல்கிறோன்னா, இட் இஸ் யூஸ் டு டிடெக்ட், ஆல்சோ இட் இஸ் யூஸ் டு மெஷர் ஆல்ஃபா, பீட்டா as well as gamma radiation. Is it okay? So we'll go with the principle. So if we take the principle, alpha, beta as well as gamma rays cause ionization when they pass through a gas. Initially I said Becquerel identified there's a gas will ionize air. So same thing, if you take alpha, beta as well as gamma rays, they ionize gases when they pass through the gas. So you take the molecules and radiation is allowed to pass through them. As you pass the radiation over the molecules, what happens there is ions will be formed and electrons will be produced. Ions and electrons will be produced, and this positive ions and electrons so formed will move towards their respective electrodes under the influence of electrical field. I'll repeat. So normally if you take this radiation, alpha, beta as well as gamma radiation, they will ionize the gas through which they pass through. So if you take the molecules, pass radiations over that, what happens there is molecules will be converted into ions, that is positive ions plus electrons, and these positive ions and electrons are formed will move towards the electrodes, that is respective electrodes. So if a positive ion, it moves towards the negative electrode, and if it is a electron, it moves towards a positive electrode. So to the respective electrodes they move under the influence of strong electrical field. Under the influence of strong electrical field, it's clear. So the rapid motion of the electron towards the anode constitutes an electrical current. So என்ன நடக்கும், electrons வந்து anode பார்த்து போகும், because it is a positive charge electrode. So anode பார்த்து போகும்போது இது என்ன produce பண்ணுனா, current will be produced. It constitutes an electrical current. It is observed as current pulse by using a leak resistance in the external circuit. ஸோ நம்மளோட எக்ஸ்டர்னல் சர்க்யூட்டில் பார்த்தீங்கன்னா ஒரு லீக் ரெசிஸ்டன்ஸ் கனெக்ட் பண்ணி விட்டுருப்பாங்க. அது மூலமாக நீ என்ன பண்ணுவாங்கன்னா, இந்த எலக்ட்ரான் ஃப்ளோ வந்து நமக்கு கரண்ட் பல்ஸாக வந்து அதில் மெஷர் ஆகும். ஸோ ஈச் பல்ஸ் கரஸ்பாண்ட்ஸ் டு an alpha or beta particle entering into the GM counter. Is it clear? So this is one thing. Another one is the positive ions formed will be quenched by alcohol or by bromine vapor, either by alcohol vapor or bromine vapor. Is it clear? So I'll repeat the principle once again, ma. So coming to the principle behind this radioactivity measurement is alpha, beta as well as gamma rays cause ionization when they pass through the gas or the molecules. So if you take the molecules, make the radiation to pass through them. Is it okay? So what happens here is the molecules will be ionized to form positive ions plus electrons. So this positive ions and electrons will move towards the respective electrodes. What do you mean by the word respective electrode? Means the positive ions will move towards the cathode and the negative electrons will go towards the anode because of the influence of electrical field. Is it okay? So now coming to the next portion, what happens here is as the electrons move towards the anode, it produces a current, electrical current, and this current is measured as an current pulse by using a leak resistance in the external circuit, and each pulse will be corresponding to the alpha or beta particle entering into the GM counter. Is it clear? So electron passing to it goes towards the anode will produce current, and this current is measured as a current pulse using leak resistance in the external circuit, and each pulse corresponds to an alpha particle or a beta particle entering into the GM counter, and the positive ions are quenched using alcohol vapor or bromine vapor. Is it clear? So this is the principle behind the GM counter. Now I'll go into the working of the GM counter, Geiger-Müller counter. Is it okay? So before going into the working principle, I'll say something about the construction. So if you take this GM counter, it consists of a copper cylinder with a thin mica or glass window at one end. You'll have a copper cylinder with a thin mica or a glass window at the one end, and a thin tungsten wire A fitted along the axis, and it's insulated from the cylinder will act as the anode. Is it clear? So I'll repeat. So which will act as anode is a thin tungsten wire fitted along the axis and insulated from the cylinder will act as an anode. Is it okay? And now Coming to the next point, it is earthed through a leak resistance or, and the copper cylinder will act as the cathode. The copper cylinder will act as the cathode. Is it clear with the point? Yes, I'll repeat. So GM counter consists of a copper cylinder with a thin mica or a glass window at one end, a thin tungsten wire A fitted along with the axis and insulated from the cylinder will act as the tungsten wire will act as the anode, and it's earthen through a leak resistance R. The copper cylinder is filled with, and if you take this copper cylinder, it is filled with, and this copper cylinder will act as the cathode. Is it okay? We have a copper cylinder, and that copper cylinder will act as the cathode, and the copper cylinder is filled with argon gas and alcohol vapor at low pressure. Is it clear? And now what you have to do is, a high potential is applied between the electrodes and radiation is led into the cylinder through the window. Is it clear? I'll repeat the point once again, ma. By seeing the picture, you can cleanly observe the thing and understand. Okay. So if you see the construction, radiation is allowed to pass through the window W. And if you take the line inside, you have a line which is said to be W, and that's a window, thin window, and along that, if you take this container, it is made up of copper, and the copper cylinder will act as cathode. And the middle point, you have a gas and marking there. Inside you have a line, and that line is marked as capital A, which is nothing but our anode. It is made up of tungsten wire. So that is your tungsten wire will act as anode, and the container is made up of copper that will act as cathode. Is it okay? And entering you have a thin glass window which is made up of glass or mica. It's kept at it's marked as W, and this in turn is connected to a leak resistance which is marked as capital R, and you have a recorder at the top. Is it okay? So the earth downward, if you see, that is nothing but it is earthened, and a potential is applied. It is shown there. A potential is applied. So now what happens here is, radiation is allowed to pass through the window W, and gas is being filled in this container. So that is nothing but you have argon gas filled in the cathode. So what happens here is, the gas will be ionized. The gas will be ionized, and what happens here is, the gas gets ionized and electrons will be produced, and these electrons will move towards the anode, causing a flow of current. This is converted into current pulse, that is said to be momentary flow, that is current pulse by the resistance R, and the pulse of current due to single particle entering into the cylinder is magnified and observed as a flash of light in the neon bulb. Now what happens is, the GM counter is capable of recording up to 5000 such pulses per second due to the entry of alpha and beta or gamma particles. Is it okay? So this is the working of the GM counter. I'll repeat. So coming to the GM counter, நல்லா பார்த்துக்கோமா. இந்த கன்ஸ்ட்ரக்ஷன் என்ன இருக்குன்னா, ஃபர்ஸ்ட் பார்த்தீங்கன்னா, ரேடியேஷன் நம்ம வெளியே இருந்து அனுப்புகிற மாதிரி காமிச்சிக்கோம். உள்ளாடி யூ ஹாவ் அ தின் விண்டோ விச் இஸ் மேட் அப் ஆஃப் கிளாஸ், அந்த கண்டெய்னர் டபுள் வால்டு, அந்த கண்டெய்னர் இஸ் மேட் அப் ஆஃப் காப்பர். இட்ஸ் அ காப்பர் சிலிண்டர் which in turn is connected to a high potential, and other side is connected to a resistance which in turn is connected, it's earthed, that we call it as leak resistance. Is it okay? And top we have a recorder, that is the recorder which records the pulse, that is 5000 pulses per second it will record, and entry of each pulse is noted as entry of an alpha particle or a beta particle or a gamma photon. Is it okay? So now what happens is, the copper cylinder is packed with argon gas. Is it okay? And your anode is made up of tungsten. And now what happens is, as the radiation is allowed to pass into the cylinder, what happens is the gas gets ionized. The gas gets ionized, and actually what happened here is, as the gas gets ionized, the positive ions will move towards the cathode. It is quenched by bromine or alcohol vapors. Since alcohol vapor is present inside the cathode, it will be quenched. Okay. On the other hand, this electron will move towards the anode, that is ionized. As soon as the gas gets ionized, the electrons will move towards the anode, and as it moves towards the anode, it is recorded as a current pulse because of the connection with the leak resistance. And this pulse, if you take the record has a capacity of observing 5000 pulse per second. So each pulse is noted as an alpha particle or a beta particle or a gamma photon. So this explanation I have given the next slide. So we can have a short glance over there. So gas gets ionized and the electron move rapidly towards the anode, causing flow of electron. And this flow of current is converted into momentary flow. That is nothing but pulse, current pulse. It is converted into current pulse by the leak resistance. And the pulse of current due to single particle entering into the cylinder is magnified and observed as a flash of light in the neon bulb which is kept inside the recorder. And GM counter பார்த்தீங்கன்னா it is capable of recording எவ்வளவு up to 5000 pulse per second due to the entry of an alpha particle or a beta particle or a gamma ray photon. So this is something about the GM counter. That is, the GM counter is used for the detection as well as for the measurement of radiation. Is it clear? So we can have a short glance of the thing what we have seen for today's class. So I have explained you clearly what is said to be natural radioactivity that is observed by Henry Becquerel. So what was his observation is, as radiation passes through a photographic plate, it affects the photographic plate, also it ionizes air, and Becquerel called them as natural radioactive material, and the process he called this natural radioactivity. Normally it is shown by elements having mass number greater than 200. For example, uranium, polonium, radium, thorium as well as plutonium. And if we take into account this detection and measurement of radioactivity, it is done by Geiger-Müller counter or GM counter, and I clearly explained you the principle behind that. And what's the principle behind that is nothing but, as the molecules are kept there, radiation is allowed to pass, ions as well as electrons will be produced, and these electrons and ions will move towards the respective electrodes. As the electrons move towards the anode, it constitutes the flow of current and it's converted into pulse by connection with the leak resistance. Is it okay? And each pulse is measured by the GM counter, and the GM counter is capable of measuring 5000 such pulses per second. It has such a good capacity, the GM counter possesses. And I have clearly explained you the working of GM counter as well as how it will be measuring this radioactive rays, that is alpha as well as beta as well as gamma photons. Is it okay? I think you are able to understand the class. Thank you for listening. Continue studying. Thank you, ma.